Good morning. Today we are continuing to graph inequalities, but now we are going to graph them when they have two variables or two letters. So we are going to be looking at the equation y equals mx plus b again. So before we get to that, we need to figure out which ordered pair or which point xy is not a solution of this equation. So if we wanted to, we could solve this for y. But what they're asking us is if we were to graph this line, let's pretend this is what it looks like. It's not a very straight line, but we'll pretend. If it's a solution, that means that it's on the line. So there could be a bunch of points on the line. So there's 4 points here. So 3 are going to be on the line. It means 1's not going to be on the line. It might be there. It might be over here. There's 1 point that's not on the line or is not a solution. We need to figure out what that 1 point is. So all we're going to do is we're going to take x and y for each of these points and plug them in for x and y. So I'm going to start with the first one, x is 0 and y is 0. So I'm just going to rewrite the same equation. It says x minus 3y, so x is 0, minus 3 times y, which is also 0, is less than or equal to 6. So we need to see if this is true or not. So 0 is just 0. 3 times 0 is also 0. So we have 0 is less than or equal to 6. Yes, 0 is less than or equal to 6, so that one works. They want to know which one's not a solution, so it can't be that one. So then let's try the next point. X is 6 minus 3 times y, and y is a negative 1, is less than or equal to 6. Well, order of operations, our PEMDAS, says we have to do parentheses, exponents, and then multiplication and division first. So this is multiply. Negative 3 times negative 1 makes a positive 3. This here is negative times negative. Then we have 6. 6 plus 3 is 9. So we have 9 is less than or equal to 6. Well, that's not true. 9 is not less than or equal to 6. So this is our answer. This one would not be a solution. If you wanted to test these, you could as well. So here they're giving us 1 point, and they just want us to tell whether it's a solution of the inequality, yes or no. So all we're going to do is plug in x and y in for x and for y. So x is 8 minus y, which is 3. We need to see, is that less than or equal to 5? Well, 8 minus 3 is 5. So it says 5 is less than or equal to 5. Notice the key word in there, less than or equal to 5. It's not less than 5. 5 is, though, equal to 5. So yes, that one is a solution. This one, for x and y, is a little tricky because there's only a y. So the only number we can plug in is negative 7. So it says negative 7 is less than or equal to 8. Well, yes, negative 7 is less than or equal to 8. So that's our answer. These ones just both happen to be yes. If we get one that was like, for example, negative 7 is greater than negative 8, or 8, it would be no. So we are going to today be graphing y equals mx plus b. So I'm going to just do a little side note here. Side note. We are going to be graphing y equals mx plus b. If you don't remember how to graph, let's say I have the equation y equals 2/3 x minus 4. What you're going to do is, let me make this a little bit better here. We are going to be graphing on our x and y axis. This is x left to right, and this is y up and down. From this equation, b, remember, tells me where to begin my graph, so we're beginning at negative 4 or down 4. And then my slope, m, tells me how to move. Or our slope, remember, is rise over run. So we're rising 2 and running 3. So from this point, we're going to go up 2, 1, 2, and over 1, 2, 3. And then again, up 2, 1, 2, and over 1, 2, 3. We could keep going up 2 over 3. And instead of up and right, we could also go down and left. Down 2 and over 1, 2, 3. And draw our line through to form our nice straight line. This is how we graph y equals mx plus b. But now instead of an equals, we are going to have like less than or greater than, and we're going to end up having to shade or color in half of the graph, either above or below the line. So that's what we're going to talk about right up here. So it says graph the boundary line. That's this line that we've normally been graphing, your y equals line, y equals mx plus b line. Then use a dashed line for less than or greater than, and use a solid line for less than or equal to or greater than or equal to. The only difference between these is this has equal to, so it's a solid line, meaning filled in. A dashed line would be like this. A dashed line is similar to an open circle when we have a number line, and a solid line would be like having a closed circle. Okay? So then we need to test a point that's not on the line to see whether the ordered pair, for example, we like to test 0, 0 because it's a really easy number to add, subtract, multiply, divide. It's easy to add 0 to see whether it's a solution. So what I was saying earlier is we're going to have to shade above or below this line. So if we test this point 0, 0 to see if it works, that'll tell us yes, we need to shade on this half of the graph, or no, instead we need to shade on this half of the graph. Okay? So we can test a point, and then it says, oops, whoa, shade the half plane containing the point of the ordered pair if it's a solution, or shade the other half if it's not a solution. Okay? So hopefully this will make a little bit more sense when we get to graph, and it'll also teach you a shortcut as well. So quick check, when do you use a dashed line? Well, dashed lines are for just the less than or greater than, and the solid line are for when we have the equal to. So let's graph this inequality. Oops. This is already in the form y equals mx plus b. So we're beginning our graph at -3 on our y-axis. Remember, b is our y-intercept, where we're crossing the y-axis at down 1, 2, 3. And then our slope, m, is how we move, always as a fraction, rise over run. So we're rising 4 and running 1. Up 1, 2, 3, 4, over 1. Up 1, 2, 3, 4, over 1. Straight up 1, 2, 3, 4, over 1. And down 4, 1 to the left as well. So we graphed our line. Move this over here. So step 1 was graph in the form y equals mx plus b. Then we need to decide what type of line. Is it solid or dashed? Well, it's only a solid line if you have the equal to. It's dashed if we have just less than or greater than. And this one's just less than or greater than, so we have a dashed line. So we're going to make, oops, this isn't very straight, but do your best to create a straight line that's dashed. You can use a ruler or the edge of your piece of paper. So once we've graphed it and decided if it's solid or dashed, we need to, step 3, test a point. As long as the point 0, 0 isn't a point we graphed. So I'm going to test 0 for x and 0 for y into this equation, just like we did on the very first slide. So my equation, I'm just going to write it, y is greater than 4x minus 3. We're going to plug in x is 0 and y is 0. So 0 is greater than 4 times 0 minus 3. Well, 4 times 0 is 0. So 0 minus 3 is -3. So is 0 greater than -3? Well, yeah, 0 and the positive numbers are greater than all the negative numbers. So yes, this is true. So if it's true, you need to shade the half of the graph. So notice this split the graph into 2 halves, above the line and below the line. If it's true, shade towards the line. So we're going to shade this direction. If it was a false statement, then we would shade the other direction. So what I mean by shade is literally color in this side, this whole side of the graph, up until that line. It doesn't have to be perfect, but just showing that side. We do not want anything below the line here. An easy way to do this, if you're not sure, or instead of testing a point in general, if you don't want to test a point, all we can do is look at our equation, our original equation. So I'm going to erase this so I can see it. And we're saying y is greater than or less than. So we're only looking at our y-axis, above the y-axis or below the y-axis. If it's greater than, on our y-axis here, these would be the numbers 0, 1, 2, 3, and down here, -1, -2, -3, -4, -5. We are greater than this whole line, meaning we are above the whole line. So going straight up from here, we would shade this half. If it was a less than, we would shade below the line. So it's the same graph we had before shaded, just a different way to go about doing it without looking at the equation. So let's try another one. What's wrong with this graph though? We need to graph y equals mx plus b, so we actually have to solve for y. So leave the y here. I'm going to move this x, that's really a 1x. It's a positive, so I need to do the opposite and subtract 1x. So you have negative y is greater than or equal to, write our x's first, -1x minus 10. And then this is a -1. To get rid of that -1, we have to divide everything by -1 because it's multiplied. Whenever we multiply or divide by negative, we have to flip our inequality. So we have y is less than or equal to, two negatives here make a positive. 1 over 1 is just 1x. And here, two negatives again make a positive 10. So this is in the form y equals mx plus b. So let's graph it. B is 10. On our y-axis, we're going to start at 10. There's 10 right at the top. And my slope is 1, or as a fraction, 1 over 1. I can't go up and to the right, so I need to go the opposite of up and right, which is down and left. Down 1, left 1. So first I graphed it. Then I need to decide, is this a solid or a dashed line? This one has the equal to right here, so that means it's a solid line. So I'm going to draw my line through it. Put arrows on the ends. There's my line. And then third, we need to shade the line, or color in above or below this line. So the cheater way that I showed you how to do it was to just look at the symbol. Like an L, less than 10 right here, below the line would be coloring in or shading in straight down. If you wanted to instead test a point, you can test any point in the whole graph that you want. If it works, shade towards that point. If it doesn't work, shade away from that point in relation to this line. I always like to test the point 0, 0 because it's easy to plug in. So looking at your equation right here, it would be y is less than or equal to 1x plus 10. We plug in a 0 here and a 0 here. Well, anything times 0 is 0. 0 plus 10 is 10. So is 0 less than or equal to 10? Well, yes it is. So if it's true, you shade towards that point, which I am shading towards that point, shading below the line. If you want to shade this way, it doesn't matter. It's still this whole half of the graph shaded. All of the sections below that line. If you want to lay your pencil flat here and bring it straight down, it would cover in that half of the graph. Let's move on and try another one. We need to get the equation y equals mx plus b. So first I see parentheses here. I'm going to distribute this or multiply. 6 times 2 is 12, so we have 12x is less than or equal to negative 24y. And I want y all by itself, so this is multiplied. I need to divide by negative 24. If I'm going to divide by a negative, I have to flip my inequality. So 12 divided by 24, we can actually divide by 12. If you want to divide by 2 and then divide by 2 again, that works, but you get the same answer. 12 divided by 12 is 1. 24 divided by 12 is 2. So we have 1/2, and it's negative. Doesn't matter if the negative's on the top or the bottom. And we have the x there. But in order to graph this, we need the y first. So I'm going to rewrite this whole thing. So I'll put the y over here, negative 1/2 x, and then our symbol gets flipped because we rewrote it. Right here, alligator's eating the negative 1/2 x, same thing here. So this is in the form y equals mx plus b, so we're really beginning at 0. And then our slope is negative 1/2, so we're really going down 1 because it's negative, and positive 2 is to the right. Down 1 because it's negative, and 2 to the right. Over and over and over again. Or up 1 and 2 to the left. So we graphed our line. Step 1 was to graph it. Next, we need to determine if it is a solid or a dashed line based on the inequality less than or greater than. This one has the equal to, so it means it's a solid line. If it was just less than, it would be a dashed line. So this one's a solid. So I'm going to put my line through it. And double check to make sure that your slope is negative. Here you said it was negative, and here our slope man would be walking downhill. Perfect. So let's take a look now at which way we're going to shade, above or below the line. So you can look just at the symbol, like an L, less than would be below on the y-axis because y is less than. So here would be greater than above. Less than would be below the line or shading down underneath this whole line. I like to put arrows there to show which direction I'm shading. So I'm going to shade this whole half the graph. If you weren't sure, like I said before, you can always test a point as well. However, you can't test the point 0, 0. No, you cannot test 0, 0 because it's on the line. You need to pick a point that's not on the line. So another easy point I would pick would be 1, 1. So I'm going to plug that into this equation. Y equals negative 1/2 x. We plug in x is 1 and y is 1. So negative 1/2 times x, which is also 1. Well, negative 1/2 times 1 is still negative 1/2. So is 1 less than or equal to negative 1? Well, no, that's not true. That's false. 1 is actually greater than, so it's not less than, it's greater than. So we cannot shade towards this point. We'd have to shade away from the point, which is exactly what we did. And if the shading part is confusing, please, please, please ask, because I can show you on your paper with your pencil a lot easier. So just lay your pencil flat and say, hey, less than would be below. So just drag your pencil this way, and that's the direction you're going to shade. I think you should try this one on your own. Solve for y, get y all by itself, and then graph it. Determine whether the line is solid or dashed. Oops, D-A-S-H-E-D, dashed. And then step 3 would be to shade above or below the line. If you would like to test a point, you can, but you do not have to. So, solving for y first, I'm going to move the y's over to the other side. I'm going to subtract 2y. So I have negative 2y is less than x, and that's a 1x. And then I want to get y all by itself, and this is multiplied, so I'm going to divide by -2. Be careful, when you divide by negative, your sign flips. And so I have 1 over -2x. Again, it doesn't matter if you put the negative with the top number or the bottom. It's just a negative number, so you know your slope is going to be going downhill. This is in the form y equals mx plus b. There's just not a b, so b is 0. We're beginning at 0. And our slope is -1 and over 2. So rise over 1, down 1, and 2 to the right. Down 1, 2 to the right. Or up 1, 2 to the left. So again, down and right because it's negative, and then 1, 2 to the right. Or the opposite of down and right is up 1 and 2 to the left. So that was graphing it. Now we need to decide, is this a solid or a dashed line? This one does not have equal to, so it's just a dashed line. So I'm going to put some dashes through here. And then I'm going to shade. Again, I cannot test the point 0, 0 because my line goes through it, so I'm going to test the point 1, 1 instead for x and y. If it works, shade towards the point. If it doesn't work, shade away from the point. So let's test out that point in our equation. So my equation right there, I'm just going to rewrite it. Y is greater than -1 over 2x. So y is 1 and x is 1. So multiplying -1/2 times 1 is still -1/2. So is 1 greater than -1/2? Well, yes it is. It's true. So we have to shade towards the point. Shading towards 1, 1, which is really above the line. So shade everything on this direction of the line. Again, if you want to look at just your symbol, greater than 0 on the y-axis. Greater than 0 would be like 1, 2, 3, 4, this direction. We're shading up, shading everything in this direction. Okay? Doesn't have to be perfect, just so that you can show me which direction you shade. Please don't shade too much so that I can't tell if your line is solid or dashed, because you also get a point for showing me if it's a solid line or a dashed line. Alright, so reminder that you can either test a point or look at your symbol to graph above or below, meaning our shading. But if you want to double check for sure, always test a point. Your homework is out of the book. Tomorrow it will be a worksheet, the last one for this chapter. So these ones are odd, and then 17 through 28 as well.